This question is from 2014. A small object is initially at rest at point O. So the object is not given here. I'll take its initial position. This is the position where the object was at rest initial, right? Point O, right? And due to an internal explosion, it breaks into three parts and move away. It was here initially. Now it has moved. It has separated to one, two, three parts. Move away. At a certain instant after explosion, the location of three moving parts are shown by the points A, B, C. At a certain instant after the location, sorry, explosion, after the explosion. So once the explosion happens, the objects, the parts are moving apart, and then suddenly they freeze the moment, and they capture, take a photograph, and they see where they are. So uh, part B has moved one block away, part A has moved 2 blocks away to the right, B has moved 1 block towards south, towards 2 blocks towards east, and C, if you take, it has moved 2 blocks towards north, 3 blocks towards west. That is how you have to analyze this. That is how you have to analyze this. All right. So the each block represents distance, right? 1-2 meters. 1 meter. This has gone 2 meters up and 3 meters horizontal, right? And in the previous question also we discussed that the distance can be directly proportional to velocity because they all have moved same time. Now, if this photo was taken after 10 seconds, this moved 10 seconds, this moved 10 seconds, this also has moved 10 seconds. So based on the distance, now if it has moved this has moved just 1 box, that means it has gone slow. It has gone 2 boxes, that means it has gone faster. Now look at C, it has gone even faster. That's why it's further away. Whoever moves slower will be closer to the initial point. Whoever has moved faster will be away from the initial point. Something like that, right? Think that way. If the mass of the part which is at point A is 6 grams, now this is 6 grams, right? I'll take it as MA is equal to 6 grams. MA equals 6 grams. What is the mass of the object in grams before explosion? So they are asking us to find this mass. I'll take it as M. I'll take the mass of part B as MB. I have already taken the mass of part A as MA, and I'll take the mass of part C as MC. MC. All right, fine. So before you start any calculations, there's something very important you have to mark carefully, and that is the directions of the velocities. B has gone 1 box down from A. Therefore, you can take the velocity of B as V downwards. V downwards. And look at A. It has moved 2 boxes to the right from the initial point. Therefore, you can consider the velocity of A to be 2V to the right. If you take the velocity of B as V, then we are doing a comparison. All right, fine. If you take C, actually C has moved along this direction. This is how C has moved. But if you take that direction, it's not useful to us at all. Therefore, we will take components of C for our convenience. All right, we will components. So this is the actual velocity of C. No argument in that because it has gone that way. But we are not going to use that. Instead of that, we will be using the components. Now let's mark the components of C. What are the components of C? It has moved 2 boxes upwards. Therefore, its upward velocity must be 2V because it has moved 2 boxes upwards. And it has moved from the starting point, it has moved 1, 2, 3 boxes towards left. Therefore, its horizontal velocity component should be 3V. Hope you all understood that. Initially, this is the initial object. I'll mark the initial velocity as 0 because initially the object was at rest, correct? And now it has exploded. So there is a momentum towards right side, and that will be balanced by the momentum towards left side. There is a momentum downwards, and that momentum must be balanced by the momentum upwards. Or you can speak in terms of east, west, south, north as well. It's totally up to you. Okay, then how are we going to find the answers? Let's start now. We know the mass of A, which is 6 grams. So we need to find the other masses. So the best approach would be to consider the horizontal momenta first and find MC. Right, let's start. Why is that? Because I know MA, I don't know the mass of B. Okay, final linear momentum towards left. I'll take towards left because C is moving to the left. It should be equal to initial linear momentum towards the same direction. Right. What is the final linear momentum in that direction? That will be mc multiplied by 3v minus, there is another momentum finally after the explosion. What is that? That is ma into 2v. C is moving at 3v to the left, A is moving at 2v to the right, and both are happening after the explosion. Final linear momentum. And initial linear momentum means this object which was at rest, 0. All right. So 3mcv should be equal to 2mav. V is common, people. We just introduce that v. We can cancel that out. And finally, what are you going to get? 3mc is equal to 3mc, mass of C. Now we have to find out 2 into mass of A is given as 6 grams. So mc is going to be equal to 12 divided by 3, that is 4 grams. I don't have to convert it to kilograms because if it's in gram, from mc also, I'm going to get the answer in grams. So that's the mass of C, part C. And then, of course, we have to apply the equation in the vertical direction. Let's apply the equation downwards. Final linear momentum equals downwards initial linear momentum. Now, why am I applying it downwards? Because I need to find out MB, and B is going down. That's why I took it that way. After the explosion, what are the vertical components of momentum? MBV, downwards, mass of B multiplied by its velocity, minus C is going upwards. Therefore, I should write MC multiplied by, what is the upward velocity? 2V. We just discussed how this 2V and 3V were marked depending on the number of squares moved. And initial linear momentum, you have to go back to the big green dot, 0. The object was not moving initially. Therefore, MBV is equal to 2mcv, and just like in the previous case, V can be cancelled out. Therefore, I'm getting MB is actually 2mc. 2 into mc is 4. Therefore, MB is equal to 8 grams. All right. Okay. Then finally, mass of object before explosion. That will be how much? That will be the addition of all 3 of these small parts. All right. Initially it was M, and then that M is the one which has got separated to A, B, and C. Therefore, if you want the initial mass, you have to add all 3 masses, MA, MB plus MC. So what is MA? Mass of A is, they have given it 6 grams, plus mass of B is 8 grams, plus mass of C is 4 grams. Therefore, the final answer is 18 grams. So in this question, the parts I have marked in dark yellow color, that is the most important part. You have to figure that out based on the distance traveled. You have to understand that represents the velocity. Why? If velocity is double, it can move double the distance because there is no resistive force. They have not mentioned anything about resistive forces. So you have to assume that there is no friction, there is no air resistance. They are moving at constant velocities. B has just moved 1 block, that means it has a small velocity. C has moved diagonally, that means it should have a horizontal and vertical component.